Good morning. I am Mrs. A. AROKIAMARY, Assistant Professor, PG and Research Department of Mathematics, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. Now let us state and prove Jensen's formula. Statement is, let f of z be analytic in the closed disk modulus of z less than or equal to rho. Assume f of 0 is not equal to 0 and f of z is not equal to 0 on modulus of z equal to rho. If a1, a2, etc. an are zeros of f of z in the open disk modulus of z less than rho and each repeated as often as its multiplicity, then log modulus of f of 0 equal to minus summation I varies from 1 to n log rho by modulus of ai plus 1 by 2 pi I integral 0 to 2 pi log modulus of f of rho e power I theta d theta. That is given f of z is analytic in the closed disk and 0 is not a 0 of f of z and f of z has no zeros on the boundary. That is f of z is not equal to 0 on modulus of z equal to rho. And there are n zeros given a1, a2, etc. an in the open disk, that is interior to the circle modulus of z equal to rho. Then we have the formula log modulus of f of 0 is minus summation I varies from 1 to n log rho by modulus of ai plus 1 by 2 pi I integral 0 to 2 pi log modulus of f of rho e power I theta d theta. Let us prove. Now consider the function capital F of z, which is small f of z into product I varies from 1 to n rho square minus a bar z by rho into z minus ai. Clearly this f of z is analytic because small f of z is given as analytic and this rational factor, this is analytic. This product is analytic. So capital F of z is analytic in any domain where small f of z is analytic. And capital F of z is not equal to 0 for modulus of z less than or equal to rho because all the zeros z minus ai product I varies from 1 to n comes in the denominator and it gets cancelled with the zeros of small f of z. So capital F of z has no zeros at all. So capital F of z is analytic and never 0 in the open disk modulus of z less than rho. Now take modulus. Modulus of capital F of z equal to modulus of f of z into the product. Now put z equal to rho into e power I theta. Modulus of f of rho e power I theta equal to modulus of small f of rho into e power I theta into modulus of the product. Then that is equal to modulus of f of rho e power I theta. Modulus of the product is product of the modulus and we can take e power I theta from numerator. So when you take e power I theta, modulus of e power I theta into rho into e power minus I theta will get in the first term. Then this rho e power I theta is taken out. Since rho e power I, now see the numerator is rho e power minus I theta minus ai bar. And denominator is rho e power I theta minus a. Both are conjugates. Okay, if you take whole bar in the numerator, you will get denominator. So both are conjugates. Modulus of conjugate are equal. Modulus of z equal to modulus of z bar. So they get cancelled. Modulus of e power I theta is also 1. And so we get modulus of capital F of rho e power I theta equal to modulus of small f of rho into e power I theta. And already we know capital F of Z is analytic and modulus of Z less than rho. So if it is analytic, we know that real part of analytic function log modulus of f of Z is harmonic. So we use mean value theorem for harmonic function. We can write log modulus of capital F of 0 equal to 1 by 2 pi into 0 to 2 pi log modulus of f of rho e power I theta into d theta. That is, we have in equation 2 modulus of capital F equal to modulus of small f. So we can replace this capital F by small f. Now we are going to find the log modulus of f of 0. So consider again capital F of Z, which is small f of Z into product I varies from 1 to n rho square minus a bar Z by rho into E Z minus ai. Take modulus and log. So I'll get log modulus of capital F of Z equal to log modulus of small f of Z. Since we have in product, we will get plus sign when we take log. Okay, log AB is log A plus log B. So applying that, this product becomes summation I varies from 1 to n log of rho square minus a bar Z by rho into Z minus ai. Put Z equal to 0. This log modulus of capital F of 0 equal to log modulus of small f of 0 plus summation I varies from 1 to n log of Z equal to 0. When you substitute, we will get a rho square in the numerator, the denominator rho into minus ai in the modulus. So we get log modulus of f of 0 plus summation I varies from 1 to n log rho by modulus of ai. Now instead of capital log of f of 0, we substitute this value and we are is here. Okay. So we get log f of 0 plus summation equal to 1 by 2 pi integral 0 to 2 pi log modulus of f of rho e power I theta d theta. Or we can write log modulus of small f of 0 equal to minus summation I varies from 1 to n log rho by modulus of ai plus 1 by 2 pi into 0 to 2 pi log modulus of f of rho e power I theta d theta. This is Jensen's formula. Now we are going to see Poisson-Jensen's formula. Let f of Z be analytic in the closed disk modulus of Z less than or equal to rho. Assume f of Z is not equal to 0 on the disk, and if a1, a2, etc., an are zeros of f of Z in the open disk. Okay. Is repeated as often its multiplicity indicates, and Z is rho into e power I theta, then log modulus of f of Z is minus summation I varies from 1 to n log modulus of rho square minus a bar Z by rho into Z minus ai plus 1 by 2 pi into 0 to 2 pi real part of rho e power minus I theta plus Z by rho e power I theta minus Z log of modulus of f of rho e power I theta d theta. Consider the function capital F of Z equal to small f of Z into product I varies from 1 to n rho square minus ai bar Z by rho into Z minus ai. And capital F of Z is analytic wherever small f of Z is analytic, and small f of Z is given as analytic function, and the product of these factors are also analytic, and capital F of Z has no zeros because it cancels with the factors. Zeros of small f of Z gets cancelled with the factors in the denominator. Now take modulus on both sides. Modulus of capital F of Z is modulus of small f of Z into product I varies from 1 to n. Modulus of rho square minus A bar Z by rho into Z minus AI. Put Z equal to rho into e power I theta. Modulus of capital F of rho into e power I theta equal to modulus of small f of rho e power I theta into product I varies from 1 to n rho square minus A bar rho e power I theta by rho into rho e power I theta minus AI. Okay. Now we take modulus of e power I theta outside. So we get rho e power minus I theta minus AI bar divided by rho e power I theta minus AI. So we know that as we have seen in Jensen's formula, rho e power minus I theta minus AI and rho e power I theta minus AI, these two are conjugates, so modulus will same and they get cancelled. Modulus of e power I theta is 1, so we get modulus of capital F of rho e power I theta equal to modulus of small f of rho into e power I theta. Now we consider Poisson's. By Poisson's formula, log modulus of f of Z equal to 1 by 2 pi, interval 0 to 2 pi, real part of rho e power I theta plus Z by rho e power I theta minus Z log of modulus of f of rho e power I theta d theta. Now we write Poisson's for capital F and then we are going to replace it by small f. Okay. So we consider Poisson's formula for capital F. Consider Poisson's for capital F. Now capital F of Z is this value. So we get log modulus of f of Z equal to log modulus of f of Z plus summation I varies from 1 to n log of modulus of rho square minus A bar Z. Using the first value, that is equation 2, okay, modulus of capital F equal to modulus of small f, and then this 4, we get log modulus of small f of Z plus summation I varies from 1 to n log modulus of rho square minus A bar Z by rho into Z minus AI equal to 1 by 2 pi interval 0 to 2 pi real part of modulus of rho e power I theta plus Z by rho e power I theta minus Z into log modulus of f of rho e power I theta into d theta. Or we can write, we need this log modulus of f of Z. So we bring the summation to the right side. That is, we have 1 by 2 pi interval 0 to 2 pi real part of rho e power I theta plus Z by rho e power I theta minus Z log of modulus of f of rho e power I theta d theta minus summation I varies from 1 to n log modulus of rho square minus A bar Z by rho into Z minus AI, where this summation I varies from 1 to n. It ranges over all the zeros within modulus of Z equal to rho. This is Poisson-Jensen's formula. See, in both Jensen's and Poisson's, we find the value of log f of, that is log f of 0 here. For in Poisson-Jensen's, we find log modulus of f of Z. That's the difference. Here, the integrand, there will be a change. Thank you.